Kia ora and welcome to video 6 of Agile Algebra. In this series we're looking at some quirky algebra problems and looking at different techniques in which we can solve them. This problem today is a fairly simple one. I want you to consider a couple of ways in that you can solve this without the use of calculus. So pause the video now and give it a go, and the solutions as usual will be after the intro music. All the best. Okay, so this is quite a nice short problem. We've got two numbers sum to 5, so start off with an equation u plus v equals 5. We've got a quantity 1 over u plus 1 over v that we're trying to find the smallest value of, so we could call this s equals 1 over u plus 1 over v. We could put these fractions together and write it as u plus v all over uv, and we know that the sum of u and v is 5, so we've got 5 over uv. We also know that u times v is the same as u times by 5 minus u. Now we've got a couple of steps here that we could use to go further. We're not using calculus. The question asks us to not use that, so calculus would be to find ds du and then make it equal to 0. Okay, that's the calc approach. We could just look at the denominator of this expression and go, it's a parabola. We're told that the numbers u and v are both positive, so if we consider that parabola, which has roots of u and u equals 0 and u equals 5, so something like that. It's a negative parabola though, because with the minus u squared, so we're actually that way around. And because parabolas are symmetrical, the maximum of the parabola is going to occur at 2.5, halfway between the roots. And that u value is going to give the biggest value of the parabola, therefore the smallest value of that fraction, given the parabola is in the denominator. So if we want the smallest value of that quantity, we want the biggest denominator. So u equals 2.5 gives minimum s, and then we can find that value of s by subbing in 2.5. So we get s is equal to 5 over 2.5 times 5 minus 2.5, which is also 2.5. So you put a multiplication symbol in there. Okay, and that comes out to be 4/5. Okay, so that's one way of doing it. Another way of thinking about it is actually to use the AM-GM inequality, which you may have seen in other work that you're doing regarding scholarships. So we've got this AM-GM inequality. Whilst NCA doesn't cover inequalities like this, it is quite a common inequality, and lots of proofs exist of it online, and it's this: a plus b over 2 is always greater than or equal to the square root of a times b. So what we do is we look at the denominator that we've got, which was uv. Okay, back to here, u times v, and we say that uv is less than or equal to u plus v over 2 all squared. Because we're told that u and v are positive numbers, when we square both sides of the inequality, the order of the numbers is preserved. We don't have to worry about flipping an inequality. And then we can sub in u plus v equals 5 into that. So we've got s is going to be greater than or equal to 5 over 2 all squared, which is also equal to 4/5. So that's like another way of thinking about this problem. The minimum value of s can be found using this inequality.